Hi, my name is Anushka Basu. I study in Modern High School for Girls. So I have the TI Inspire calculator and I've been using it for like 1.5 years now. And I use the calculator for academics. So mainly I use it for for my maths class. But along with that, I also use it for my science subjects like biology and chemistry. And then the calculator TI Inspire, it is very useful and it's very easy to handle. So before this calculator TI Inspire, I had the TI 84 plus CE, and which was also a very good calculator. But after exposure to the TI Inspire, solving sums have become really easier. So some of the exclusive features of TI Inspire are we can graph Voronoi diagrams, which is a part of our IB syllabus, and which is not I cannot draw those in the TI 84 plus CE, that calculator. And then graphing a function in this calculator is very easier because I can just input the function and the graph is like it's readily drawn. But whereas in the TI 84 plus CE, there were like numerous steps to just draw a graph. And doing statistical problems, it is also that are also very efficient because there is a specific feature for of a spreadsheet in the TI Inspire. And the best feature I like about TI Inspire is that we can save documents and have multiple pages open where we can do different questions or parts of the same question. So, like during our exams, if there are like multiple parts to a question, then we can simply like open different pages and have solve them separately. Then so initially when I got the TI Inspire last year, I was very confused, like what to use for like specific functions, and thought that along the sum, and even thought that doing the sum manually would be easier for me. But after like attending many workshops and webinars by Texas Instrument, I am able to grasp all the functions and nuances of the calculator. So now I cannot do a complicated math problem like without the TI Inspire. So it's been a really it's this calculator is really helpful.
Hello, friends. This is Krish, and with me there is my friend Abhay. And today we are going to tell you something about our experience with the TS softwares and the handheld. So let's go. Our experience with the handheld and the TS softwares has been extremely wonderful till now, and we genuinely love the software and the handheld. And we're pretty sure that it's going to be way more amazing in the coming years too. Having the TS softwares and the handheld was really helpful for both of us because we literally use it each and every day when we do the calculations or even in other subjects to do stuff. And we are actually love it to such an extent that I and Abhay actually created a YouTube channel called Crab GDC, through which we actually want to pass on our knowledge about the TS softwares and the handheld to our peers too.
The first question is how do we come to know about the GDC and TI softwares? And the answer to that is that Heritage actually required us to purchase the TI Inspire CX calculator, since it's a pretty useful tool employed by a lot of IB schools around the world. And the calculator does help people in most of the sciences and maths. So the second question is, since when have we been using them? And since Krish and I chose international maths, we started using it in ninth, and we will continue to use it for the diploma program and for tests like the SAT. New concepts and implementing interactive methods of teaching. So I personally loved the TI because it helped me start out with modeling, something that I now really like, and it gave me a base for that concept. Even though it can't do a lot of complex things, it did spark an interest and it did help me build a base in that concept. It's also really great for subject tests like the SAT and ACT, and also good for IGCSE and IB.
Good evening, everyone. I welcome you all for today's session, which is hosted by Numerical Analytics Instruments Private Limited. Thank you all for joining with us, where we are going to focus today on the topic sequence and series. So let me first introduce myself. My name is Swati and I am the trainer at Numerical Instruments Analytics Private Limited. Before moving ahead, let me first brief you about the company. Numerical Analytics is the leading provider of modern education technology and the analytical technology. Its presence in India is since 2008. The head office is in New Delhi and the main office is in Malaysia. Under the education technology, we are the sole distributors of Texas Instruments across India. That includes the graphing calculators, the scientific calculators, and the financial calculators. We work with many educational institutes, schools, colleges, universities across India. Along with TI calculators, we are also the distributors of science equipments like the probes and sensors of the vernier. All the vernier probes and sensors are compatible with TI calculators. Therefore, the calculator can also be used for science subjects as well. The other division of numerical analytics is the analytical technology, where we support the research analyst to avail the leading qualitative and the quantitative research softwares in India. These softwares are basically used in colleges, universities, etc. If I talk about our partners are the Texas Instruments for the education technology and the eViews and NVivo for analytical technology. We have been dealing with many IB and IGCSE schools across India. So I have brought you some of the schools over here because the list is really long. So let me just have a look at some of the schools, like the very old school, Kodaikanal International School, all the three branches of American Embassy School, Chennai, Mumbai and Delhi are the users of TI for a very long time. The most reputed school in the Mumbai, the Oberoi International School, the Heritage, the Pathways Group, the Indus International, and the Srinidhi, Navrachna, all are the users of Texas calculators. So before moving to the calculator part, we will also have the Q&A session towards the end of the webinar. Also, the webinar is recorded, so we will be sharing the recording of it with all our participants. Now, TI Nspire CX2. This is the latest version, latest technology. So let me talk about the keypad first. The layout of this calculator is divided into three zones. The first one is the navigate zone. The second one is the math numeric zone. And the third one is the alphanumeric zone. So in the navigate zone, you have this navigation pad, which helps you to navigate around the screen. And if you see about the keys, the key written in the blue, all are the secondary functions, which can be accessed in combination with this control key, the blue color control key. So this control key plays a very important role. So in this math numeric zone, we have some mathematical numbers, the numerical numbers, and some mathematical keys. You can see the trig key and all over. And under the alphanumeric zone, you have all the alphabets from A to Z, and you also have some keys which we will discuss. Also, this calculator is kind of a laptop because you have many shortcut keys as you have it in the laptops. The first is the escape key, which helps you to come out from any existing field. The next is the tab key, which is very useful and used every now and then. It is used to move from one entry field to another. Next is the control key, as we have already seen. The shift key, the delete key helps you delete the functions or anything, and the space bar. So all these are computer-like keys. They function as the computer does. This calculator, the very important key is the menu key. The calculator is completely a menu-driven calculator. Now, when I talk about some of the buttons in this calculator, under the control key, you have an equal to sign, and above equal to you have various keys. So all those keys are known as relational keys. So these relational keys can be accessed in combination with control and equal to. So you have all the keys greater than, lesser than, equal to, not equal to, and everything. Beside this, you have the trig key, where you can see all the trigonometric ratios and the inverses of it. And then in the alphanumeric zone, you have this pi key, where you can see all the conversions in it: iota, infinity, exponential, degree, radian, gradient, and everything. Here you have the punctuation key, where all the punctuation marks are there. And then this one, beside the number 9, you have this very important key known as the math template key, where you can see all the mathematical templates like the matrices, sigma, summation, integration, differentiation, logarithms, and everything. And beside this, you have a catalog key, which is again a very important key. So in this catalog, you can see all the functions that are there in this calculator. So you can see all the functions along with the syntaxes of it. For example, I take my nsolve. So when I click on nsolve, you can also see what is the syntax exactly it has. So in this, you can get all the keys here. So this was about some of the shortcuts and the keypad layout. So let us explore the concept of sequence and series, our today's topic, by one of our T-Cube trainer, Mrs. Shraddha Nayak. So let me first welcome Mrs. Shraddha Nayak. Mrs. Shraddha Nayak is currently heading the math department at Oberoi International School and is also an IB examiner. Previously, she has taught at American School of Bombay and in international schools in Japan and Malaysia. As an educator for over 20 years of experience in integrated math program, MYP, IGCSE, and IBDP, her focus has now been on how mathematics is contextualized across the wider curriculum alongside students' discrete mathematics learning. She provides instructional leadership and supports curriculum enrichment. She holds a master's degree in science, Bombay Universities, and master's in secondary education, New Jersey, USA. Over to you, Ms. Shraddha, ma'am.
Thank you. I'll share my screen. A warm welcome to all the participants. And I will quickly start because we have a lot to discuss. So I'm going to share my screen. Is it visible?
Yes, ma'am.
Okay, right. So today the focus is just on sequences and series, but through this workshop, you would be able to appreciate how different applications can be used and how they're dynamically linked. So I'm going to use examples across the curriculum, the AI curriculum and the AA curriculum, right, for both standard level and the higher level. So just to, I want to let you know what I'm going to demonstrate. So these are the more important applications for this topic would be the calculator application, the spreadsheet application, and the graphs application. And of course, the finance solver, which is really useful for the AI as well as the AA, especially for the AI SL students. So let's get going. So before I use some examples from the IB question papers or from exam style questions, I'd like to first show you how this can be used, these applications can be used. So this is a notes page, all right? I've had some notes for you. So what are the kind of applications I'm going to use? Every time, if you see here, there will be, I'm just going to scroll across. I've got about 7 or 8 examples, all right? I want you to focus on the nomenclature, how I've named it. If you see, there's a 2.1, there's a 3.1, there's a 3.2 and a 4.1, and so on, right? So all those that have these numbers, the 4, there is a new problem, all right? There is a new problem. If there is a new problem, I've put it on a problem set, and I'll explain that to you. So you have 2 choices when you're adding, you can either add a page or a problem. So my advice to you is that if you're starting on a new problem, you have to introduce a problem, all right? So I'll let you know where that is. If you go on the doc, so even before we start sequences and series, this is something very fundamental for you to know. If you go on the docs page, right, you have the insert, and you have the choice of either the problem or the page. So every problem that I'm going to show you is on a different problem, which is displayed here on my TI, all right? And there are additional pages to every problem. So what I mean is the 3.2 here, if I want to escape now from this, I use the escape. So the 3.2 is a link to the 3.1, all right? And all work that I do in the 3 problems, additional pages in the 3 will all be linked. And you will be able to see what I mean in just a minute. So I'm going back. So that was important for you to understand. So when we go back to my first thing here, right, I want to show you a few things that we can do on this calculator. So I'm going to see, if you see this is a problem, which is problem 1, I want to add a page because I want to show you what these can be done. So the way that you add the page, all right, if you see the plus page here, I'm just highlighting, placing my cursor here, the plus page, everything with the blue is controlled by the control key. So if you want to activate the plus page, you've got to press the control. So I'm going to do the control plus page, and I have a choice of these applications. All right, I talked to you about the calculator application, the graph application, and the lists and the spreadsheet application. These are mainly that we are going to use. So I want to first use the calculator operation. So if I go here back, right, I want to show you some of these, and eventually through the workshop, you'll see all of these used and some more maybe. So I'm going to the page that I added. I want to show you something. Ms. Swati, she discussed about the math template and the catalog. In the catalog, there are several commands that you can use. I'm going to use the sequence commands. So I'll show you what I mean, all right? So if you go down, if you scroll here, this is the catalog. All the commands are housed in this, under this catalog. So if I go down, and if you see, I have to go up a little bit because we are looking for sequence, right? These are the commands we are going to use essentially. So you see the sequence and the sequence end. If we have time, I'll talk about the sequence generator. So I'm interested in the sequence. So one thing you could is highlight on this one, all right? So if I'm going on here, right, you see what is displayed at the bottom. It gives you an insight into what has got to be entered. If this has to be worked out, you need the expression, you need the variable that you're using, and the low and the high. So how many terms you want. So let's go back. I'm going to, again, so this is one of the ways to get to sequence. I'm escaping this because I want to show you a different way of getting there. You can even type You can even type, I'm just getting this out of the way. Yeah. Okay, you can even type SEQ. So I'm going to type SEQ. It is as good as going on to the catalog. And then, as you saw, the command was to have an expression. So let's say my expression is 2x minus 1. I'm going to start from something very basic, all right? If you know this is the command for the odd numbers, and then I need to define the variable I'm using. The variable I'm using is x, so I write in the x. The comma is for how many terms you want to start. I want to start from the first to the sixth term. So I say first to sixth, all right, and I close the bracket and I press enter. And you'll get a set of your odd numbers for the first 6 terms, all right? I could store this. And I can do many different things. So let me show you how to store it. Since these are odd numbers, I think a good way for me to remember when I want to recall is storing it as odd. So I'm going to write odd. And if you see here, the store, again, the store is controlled by the control key. So I say, okay, I want to store this. This has already been defined by me. So just hold on. I'm just going to delete this. I'm just going to call it OD because I've already, when I was preparing the slides for you, I've already defined you. So right now I'm going to call it OD and store it. And what I can do is copy this here, paste it here, and okay. So so this has been stored, all right, already. So what I'm going to do is I'm going to find the sum of these numbers. So I'm going to write the sum, right, and going to go to my variable. It's already defined, all right, and I'm going to press enter and I get the sum. This is one way to get the sum of these numbers. What I could also do is I want to show you what the sequence n can do. So I'm going to write the sequence, all right, and the n. Now, this is an abbreviated version where I don't have to use so many different parameters. You know, there's 2x minus 1, there is x, there is 1, there is 6. So this is an abbreviated version, a shorter version to get a sequence. But this one uses only the variable n. So what I'm going to do, I'm going to show you, I'm going to get the same thing using 2n minus 1 this time, right? And I'm going to say, this is because it is sequence n, it assumes your variable is n, so you do not have to specify n. It also assumes you want to start from the first term. So all you have to do is write the number of terms. And let's say I want five terms, and I press enter, right? Now, one of the other ways that you can, because let me go back and, okay, some of the things that we discussed here, all right? I want to show you what the summation is. So you go to the catalog, you go to the math template, and you see the summation sign. It helps you find the sum. So I'm going to press this, right? I'm going to use this because we have already figured what the sum is for the first 6 terms. So I want to show you how it can be done in a different way. So I use the 2x minus 1, right? So the same sequence, I could use any other sequence, right? And I'm going to say my x, since I want to find the sum of the first 6 terms, right? Go in here, click in X and press enter, and you still get the 36, right? So finding sum of sequences can be done in different ways. this is this is the best way you can do it, because you just have to, there's just one command. You don't have to remember any other extra parameters that go with the command. So this could be some students may prefer to use the summation, the sigma notation. All right. So now let me move on to some of the questions, like what kind of examples would you see? So let us try and do this one here, right? Find the 20th term of the following sequence. I'm going to focus from the arithmetic, move on to the geometric, then do a combination of arithmetic and geometric, and then finally I will do the finance problems. So let's say I want to find the 20th term of the sequence, right? So the first, so this is an arithmetic sequence, because if you can see, the first term is 5 and it has a common difference of plus 5. So one way you could do is define. You have a formula booklet and you have all the formulae which are given. You have the formulae for the arithmetic sequence, the geometric sequence, the sum of those sequences. So you could use the formula booklet and the calculator to define, right? So what I'm going to do right now is going to define the sequence. And I'm going to say, okay, I'm going to use S of n, all right. Okay, S of n, and I'm going to define it, and you will see why. There are 3 questions that there may be different parts of the question, and defining becomes really important at that time. So I'm going to show you different ways of doing it. So first I'm defining. So when I define my sequence here, right, I know, you go back to this, you know the first term is 5 and the common difference is 5, and I want to find the 20th term. So I'm going to define the first term is 5, okay, plus, and the difference is also 5, and I'm going to multiply it by n minus 1. Now what is the advantage of doing this? This is because you are using directly the formulae from your book, from your formula booklet, right? And when I define this, now when I want to find the 20th term, all I have to do is write S. Now do you see the difference? Here is where I have defined the S of n, and it has turned bold because it can recognize that it's already been registered. And I want to find the 20th term. So I do S of 20, right? And I press enter, and there I go, right? I could also find the sum. I could do different things because I have defined. And you'll see this examples, you'll see this technique used in the questions I'm going to do later. Let us go to the second part. It says the first 3 terms of an arithmetic sequence are 8, 1, and negative 6, and find the term that equals negative 258, right? So examples like this can be really, really solved. So I'm going to use the same technique, and I'm going to do here, and we're going to say, let me define this, all right? So if you see, the first term is 8, and the common difference is negative 7. The common difference is negative 7. So what I could do is I could say, okay, I'm going to define this. So I'm going to call it T because I have already used up S. You can use any of the variables here and define it as T of n again, right? I can define it. The first here, going back, let's see. This is 8 and this is negative 7. So I go back here and I say, okay, I'm going to define it as 8 plus negative 7 multiplied by n minus 1. Okay, close the bracket, enter. There are several ways to do it. I'll show you some other way as well. And now I can solve. So I can go here. I can go to solve, to the numerical solve. All right, this solves, and I can say, okay, my T of n go back to the question. It says it is negative 258. So I'm going to say equals. The equal sign is here. And it is negative 258. Okay. I'm interested in finding the variable is n. All right. And I press enter. And the answer is 39. So once you define, there are several things you can do. The calculator remembers the parameters that you've set for it, and you can solve. Alternatively, I could have just written this. I need not have defined. So I'm going to show you the same thing. So go here, we go to algebra, we go to numerical solve. Now, one really cool thing about this calculator is I can go up and I can copy stuff from here, right? I can copy this stuff here. Okay, so if I want to do this one here, I can just copy it and paste it here. So I'm not defining it, but I'm still solving. So I can go here and copy it down here. So it's the same thing. I haven't defined it, but I have expressed it as an arithmetic sequence, and now I'm going to solve it, and I still get 39. So there are several ways you can do it. Let's go to the third one. All right. Now, if the third term, so this is interesting because we are going to use still a different application, which is for solving simultaneous equations. If the third term of an arithmetic sequence is 4 and the 8th term is negative 11, so you should know that you need to use a systems of equations where the third term is defined as a plus 2d, right? So I am going to show you the use of a different function here. So go to menu, you go to algebra. Now you can also, I could have also clicked 3 here to get to algebra, for example. Now I want to solve a system of equations. I can just click on 2 when I am on the algebra here, right? I'm on algebra. So when I'm on algebra, I can click the solve a system of equations, or alternatively, I could have pressed 2 to get to this operation, right? Now the number of equations are 2 because your number of unknowns are 2. The first term A and the common difference D. So my number of equations are 2, so that's good. Now to move between these fields, as Ms. Swati, if you remember, Ms. Swati had informed us that you should use the key tab. Okay, so to move down, you use tab. I just want to show you how it moves in rotation. All right, and then I go down to tab, and there is no need of expressing it in terms of X and Y, right? I can use A and D because that brings me a sense of comfort at times, because that is what you want to find. So I can go back here, I can change these, and I can write A, and instead of the Y, write D, because A being the first term and D being the common difference. And again, I use my tab to say I'm okay with this, right? Now, if you see here, I've got a system of equations. All I have to do, it was the third term. So it was A plus 2D equals 4, I believe. It was 4, right? I can go down and write. So I just want to make sure I read it correctly. So the third term is 4, and the eighth term will have 7 differences added to the first term. So I go back here and I say A plus 7D, because it is the 8th term, 7D equals, it was negative 11. Always remember, you have to use this negative. This is subtraction. So this is negative 11, right? And then I press enter. And you have your first, since you have your A, the A is equal to 10 and the D is equal to negative 3, right? So If you go back, I just want to revise the kind of applications that we used here. We used the sequence generator, the sum and solve. We understood how to store variables. We still have to do polyroots. We did the summation, that is the sigma notation. I'll show you how to do the fraction to decimal conversion. We've defined sequences and we have used simultaneous equations. So I'm moving on, right? We are moving on. Okay, now if you see, again, the 2.1 and the 2.2 are belonging to a same group, all right? I'm moving on to the 3.1. Anything I have defined in 2.2 stays with the 2. You can still define in 3, you can still use T of n, again, if you have to define a sequence. And that is the essential part, or that is a very distinguishing feature of TI. You can create problems and you can create pages. You can add pages to the problems, right? This is its unique feature. So you go to 3.1, we have a different question here. Now, these are some of the questions that you would find in the IB question papers, very similar to those. This would be AI SL question. If you know, the AI SL and the AI HL, they're subsets, which means a part, 60 hours of your syllabi is going to be common between AI SL and the AI HL. So your questions will have components that are common to SL and HL, all right? So we go to question number 1 and we'll do this, all right? Now, when I said defining a sequence is really, really useful, it is really useful in questions that have subparts. Because when you're once done with defining, you can use the same feature over and over again for the 3 sub-questions, right? So let's do this. Again, I'm going to add a page, all right? I'm going to add a page. I've already added a page here to show you, all right? Okay, since we have so much to cover, I've done this bit and I've shown you. So I'm going back to the question. It is 500 and the difference is 10. And if you see, A is 500, I've defined it as UN. And I found, again, go back to the question. It says find the 25th term. And that is why I found the 25th term, it is 260. If I want to find the sum of the first 25 terms, we have done this, and that is why I'm going to rush through this. There's so much to cover, right? And this is what I've shown you how to do this in the earlier question, and that is how we find the sum. Now, we've also used Nsolve, but this is different. So I want to do this with you again, right? Okay, so look at the question. This is a different question. It says, how many terms need to be added for the sum of the terms to become negative? So let's go back. Let's revisit this. So I've got this. I've done the Nsolve. All right. I've done the Nsolve. And, you know, I think I want to do this with you. So I'm going to kind of, you know, show you how to do it, because there's a lot to it. And that is why I'm going to. Okay, so we are here. I'm going to redo with you so you get to understand, right? And this is what I have done. This is the sum. But now notice, I haven't written it as a negative. All right, I've written this at equal 0 because your interest, you want to find, and this is the formula for sum. I want to remind you, this is the formula for the sum of an arithmetic sequence. All I have done is plugged in numbers. For example, all right, your first term is 500 and the formula is 2u1, which is 2 times 500, and I could have also written 2 times 500. It wouldn't have mattered. Okay, okay, I could have done that as well. Minus 10 is the difference. This is the formula which is given in your formula booklet, right? And I can't have a negative, like I can't write it says less than, it is negative. So I want to find the term that when added will give me the first negative, right? And I try and do this, I get a 0, which is correct, right? If you plug in n equals 0, of course, this is going to be 0. But there are two answers. If you notice, this is a quadratic. Okay, the sum of an arithmetic sequence is a quadratic expression. So you will get two answers, and this is one of the answers, all right? So how do I use NSolve? So this is, again, I'm going to, as I told you, you can go back and you can, so I can, and go up. So I'll show you what I mean. I can go up using this, right? And press enter. So it will be copied down. Now this time, I'm forcing the calculator to give me the answer. And I will explain to you what I mean by that. So it says, okay, given that n is greater, if you recall, Miss Swati, she discussed about using the relational keys, and I'm going to use relational keys. I'm going to say, oh, n has to be greater than 0 because n is the number of terms. So n can't be negative. So 1 is 0. The answer to this expression is 0. What is the answer? So you're forcing the calculator to give you the answer. And that is why you get n equals 101. Now, the limitation of NSolve is, if you're going to solve, you're going to use NSolve for a quadratic, it only gives you one answer. So here, the answer to this expression is, there are two answers, there are two solutions. One is 0 and the other is 101. So I still used NSolve, and I said, now give me the other answer where I have added a condition. I say n has got to be greater than 0. All right. Now, alternatively, what I could do is I can get the same thing using polyroots. Okay. So I will show you how to do that. We go to menu. You go to algebra. Now, when would you use polyroots? You'd use it to solve any equation that is higher than the linear. Since quadratic is higher than linear in terms of the degree, so I'm going to find the roots. All right. I say, okay, 2, I'm doing the same thing. And again, we know that we have the real roots. Again, we use tab to move between fields. Okay, I say, okay. I go back here and I say, okay. And it tells me to fill in the numbers. Now, I've solved this earlier before I could, so I've solved the NSolve, the expression inside. And when I solved it, it was 505n minus 5n squared. So my A2 is -5. Okay, I move the tab. My n is 505. If you haven't understood, I will just explain in a bit. And the C is a 0. Okay, and I press OK. Okay, so let me explain. I'm doing the same thing in a different way. So what I did was I have expanded this. The n over 2 times 1,000 multiplied by 1,000 plus -10 multiplied to n minus 1. I have expanded that to get this expression. It is -5x squared plus 505x. All right. So I'm still finding the number of terms. Now, when you use polyroots, you do not have an equation, you have an expression, you're solving for x. And I press enter and I still get 0 and 101. I hope you made the connection. When you get NSolve, you only get one answer at a time. And that is why I used the NSolve, but I kind of nudged the calculator by giving an extra condition to get the second answer. But I could have done so. If you want to solve for equations that are higher in degree than the linear, you've got to use polyroots. This is a quadratic equation, and I got the same answer using polyroots. Okay. Now I want to check. I want to see if my answer is correct. How do I do that? Okay. So go back to the question. It said, how many terms are needed to be added for the sum of the terms to become negative? So if you need 101 terms, let's check if that sum gives me a negative answer. So I'm going to the math template. I'm using the sum and I'm saying, okay, the sum of this, which was, you go back up here, right? And this is what you're looking at, right? This is the expression. I'm going down, right? And I'm saying n equals 1. And I know it is 101, but I still want to check. It should give me a negative answer. So it is equal to 0. It gives you 0. Now let's go back up and get it again and say, I want to find this 102 terms, and you press enter and you get your negative answer. So the first 101 terms give you a sum of 0. When you do the sum of the first 102 terms, you get your first negative sum. Let's go back to the question. How many terms need to be added for the sum of the terms to become negative? The answer is 102, right? I showed you the same thing in several different ways, right? So let's move on. You will notice it is a different question. I'm moving on to geometric sequences. And if you see, this is 4.1. The reason being, I want to be able to use I want to be able to use the variables, the defined functions once again, so I don't get mixed up. All right. And it is really very easy. So if you are really struggling on a question, you can move on to the fourth question and come back to the third later on. So there are several advantages in having this distinct feature of being able to add a problem in a page. So let's do this question. All right. Consider a geometric sequence. Find the smallest value of n. All right. Now, I told you we are going to use the graphing. Let's use the graphing for this one. All right. So if I've graphed it, I'll take this opportunity to show you how to undo the page. All right. So I'm going to go back to the control. So I'm going to delete this page because I want to work on this page, right? But if I've already defined U1, so it will not agree to it being redefined again. I want to also, the reason I've kept this page is because I want to show you how to delete some pages. So I go on to control and the up key, right? And if you see, I've got the arrangement. It was problem number 4. I said I want to delete this. I'm going to delete this. I'm going to problem 1. Okay. And I'm going to problem 1. And if you see, the 4.2 has been deleted. So I'm going to add a page. That was the whole reason I did this. So to add a page, you'll do control doc because it says plus page. All right. And this time I'm going to use the graphs. Let's revisit the question again. It says, this is a geometric sequence. Find the smallest value of n, which is less than 10 raised to negative 3. So 1 over 1000. So let's go here and let's do this problem. You can do this problem on the calculator application as well, but I want to show you a different feature. So when you're in the graphing page, you go to the menu, and the menu is the best thing on this calculator because it kind of responds to the to your requirement. Right now, because I'm in the graphing, if you see, it has got the menu which makes sense on the graphing page. I'd need the graphing entry, I'd need the window, I'd need to trace, I need to analyze, right? When we were in the calculator application, there was the algebra function where you had to solve or find roots. So this is kind of intuitive, right? It responds to the need for that particular application. So in this case, I go to the graph, right? And since it is a sequence, now sequences are functions that have discrete numbers in their domain, and that is why I am going to do the sequence, right? I'm going to go to the sequence, right? and I can go, if you go tab up, okay, right. Okay, and I'm going to define this now. I'm going to use this 18 times half raised to n minus 1. So I'm going to do 18 multiplied by half. I could use the fraction. I'll take the opportunity to show you the fraction, right? And this is a half. I could have alternatively used a 0.5 and raised to n minus 1. Right, okay? And I'm going to graph now. This is a sequence and your n cannot be negative, and your n, it is already defined for you. It will take any values from 1 to 99. So I'm good. I'm going to graph this. All right. Now, if you see, I really don't have any need. So this is the graphing. This is the first, this is the third term. If you see n equals 1, it's still higher. We can't see the graph in its entirety or the more important bits of the graph. So I can adjust my window in several ways, right? I'm going to show you a couple ways, all right? So I'm going to change the scale, the values here, and I double click to kind of highlight it, and I say, oh, I know the n can't be negative. So to get a viewing, to get a good view, I'm still going to have a -1 here. If I want to move on to the next one, right, all I have to do is do tab. So tab is a really important key. It moves between fields. So I go to tab. If I'm interested in changing these values, you know, I'm going to do 25, and I tab again, and I say, I want the first 20 terms, and I say, okay, this window is okay, so I press enter, right? So do you see the graph, right? This is the first term, this is the second term, this is the third term, and it's kind of defines for you. Okay, here it will define for you. Right now, let's go back to the question. The question says, find the smallest value of n that is less than 10 raised to -3. So I go back here. Several ways to do this again. I'm going to go to menu. Again, it is a contextual menu. Okay, I'm going to trace. I want to find the coordinates of those terms. So I'm going to graph trace. And if you see, I can use my left keys and the right keys, the navigation keys, to scroll left and right and to find the value, right? The U2, when n is equal to 2, the term, the value of the term is 9. And I move to the right, 3 and 4.5, and move on. You've got to find a value that is less than 1/1000, right? You might have noticed that this is a converging series, okay? The number, it never becomes 0. That is an important aspect of a converging series, all right? It tends to 0. It approaches 0 in this particular example. And so when we are looking at the, and you will also see the discrete values, because it is only defined for integers, for positive integers, right? So I can move my navigational keys and I say, okay, yeah, but I still have difficulty in finding this, right? Like, okay, it is 1/. So when it comes to this, all right, I do want to point out that on your examination, you cannot use e raised to -4. You got to understand that the e here means it is 10 raised to -4. So if you are confused, you say, okay, I do not know, it looks like it could be n equals 15 because it's 0.001, but I don't know if there are additional values here. So I'm confused between 15 or 16. No worries. What we could do, we could open up a table here. So if I do Control T, I get a table of values. And because I was confused whether it was 15 and 16, I can scroll down to those values. Okay, I can scroll down to the values and check the actual values and say, okay, oh, this is still a little, this one is farther away from 1000, but this is not the right answer because this is 0.001099. Well, this is smaller than 1000. So the answer is U16. I'm going to do the same thing in a different way. I could have used a calculator application. I also want to show you that. So what I'm going to do is add another page because it is the same problem. So I'm going to add another page by doing Control Doc. All right, and this time I'm adding a calculator. And I've already defined, if you see, this has been defined, right? This has been defined as U2N. So what I could do is I can go on this one and say, I want to find out, right, U2 of 15. You get the same thing, but I'm showing you different ways to get it. And if you see, the U2 is defined, even if you define it on the graph, you do not have to define it on the calculator application. You just, only the calculator application will not take the defined values. You can also define it in all applications. So this one I had defined in the graph, and I'm going to press enter, and I get the value. Now I take this opportunity to show you how to convert the fraction to decimal. So if I do Control Enter, I get the decimal. All right. So I read the decimal. Now I do the U216. Now this is very important in IB exams. You have to show your working. You have to show how you have finalized your answer, or you have arrived at your answer as U16. So you got to show that U2 of 15 is 0.001099, and now I'm going to do U2 of 16 and press enter. And this one again, I'm doing Control Enter, and I get the answer. And that is why the answer is the 16th term, because it is less than 1000. All right, so we go back here, and this was our question here, right? To find the sum of first n terms, you can still use, because this is geometric, I'm going to go in here and I can, do this again, and my n goes from 1 to, is it 7 terms? So I'm going to go to 7, and I'm going to write 0.5 times, sorry, what was it? It was 18, was it? Yeah, it's 18. I'm sorry, just 18 multiplied by 0.5 raised to n minus 1. Right. And I press enter, and this is the sum of your first 7 terms. I've shown you it works for the arithmetic. You can use it for the geometric as well. You could have also used the formula given in your formula booklet to find the sum. Let me go to the next question. All right. The first term of an infinite geometric sequence. Now, for an infinite geometric sequence, it's got to be a converging. So the ratio has to lie between -1 and 1. All right. And the sum of the finite sequence, the sum of the infinite sequence is 200, right? So we are going to use, so if I have, since we are out of time, I'm just going to show you how I've done it. Right. So it is an infinite geometric sequence. You have a special formula for the infinite series, which gives you the sum to infinity, right? The sum of the infinite sequence. And that is why I've used this. If you see here, going up, right? And I've said the sum of infinity is 4, which is the first term. Let's go back. The first term is 4. And this is the formula. 1 minus r, u over 1 minus u1 over 1 minus r, and I've solved for r. So I've solved, I'm showing you the use of nsolve. I figured out that it is 0.98, and I used to find I use the 4, the first term, and the ratio that I found to find the sum of the first 8 terms, right? And now going to the next question. It said, find the least value of n for which the sum is greater than 163. If you see, I have used the n solve again, and I've used the sum formula because it says the sum of the first few terms. You've got to find, it's not an infinite, it's for the finite sequence, right? I use the formula, solve for n, and that is how I have gotten 83.5. Again, I want to show you that I plugged it back to see which, is it 83 or is it 84? Does it lie between it? Because 83.5 cannot be the value of n, since we are solving for n is an integer, and you might get confused whether it is 83 or 84. So I use the summation to check the answer. When n is equal to, when n is from 1 to 83, the sum equals 162. But when you have the sum of the first 84 terms, the sum equals 163. So the answer is 84. All right. Let's move on to the next one. All right. I do not know if we have time for this. I want to show you, Ms. Swati, do we have time?
Ma'am, we can take for another 5 minutes and then maybe we can have Q&A session.
Okay. All right. Do you want to have the Q&A session now, and we can have a part 2 for sequences and series, because there is a lot of finance questions also left. So,
yes.
yeah?
Yes, ma'am. That will be better.
Yeah. Okay. Because I don't want to rush, and it's
Yeah.
a lot of things. So this is a question which is a integrated question of the arithmetic sequence and the geometric sequence. There's a lot to it. So maybe I will take the questions now. Hi guys, do you have questions for me?
Ma'am, we have a question in Q&A.
Yeah.
The student is asking, can we do the graph question again?
Sure. Which graph question?
I think the previous one.
This one?
Yes, ma'am. I guess this one. We can also check with the students, like if you have any doubts, you can raise your hands and we can unmute you.
Yeah, I think you can be more specific. If I can do this question again, okay? If we are looking at this question, okay? So what I'm going to do is I'm going to make, I'm going to add, I'll show you how I will add a question. This is notes page, and I want to use the same, possibly the same defining parameters. So I don't want to get confused. So I'll show you how to add a problem, okay? Because we've shown you how to add a page. So I will do the same thing here, and I will go to the document. I will insert, this time I'm going to insert a problem. All right. I'm going to, because I have to, you would not use the notes page as often as I do. All right. And I'm going to get this question. Now you see, I can still use, so I'm going to use here. Let us go back. And if you want the entire question, I can kind of just, copy and paste. It's just so easy. Right? So let us do this. All right. So several ways you can do this. Let's say I want to do the graphing one. All right. When we'll do it with the calculator as well. So let me add. Now this is a new problem. I'm going to add pages to this problem. So the way that I do that is several ways to do it. I'll show you two, and you can choose your preferred one. You can go to doc, you can insert, and this time insert a page. All right. I want to get out of this, but I want to add a page directly from here. I can do control doc, and I can add a page, and this time I want to add a graph. All right. Now, since this is not a continuous function, that means n for all real numbers, but just for n for integers, I want to graph the sequence. So I go to the menu and I go to the graph entry, right? It is not a function, not a relation, it is a sequence. So I graph the sequence. And now I'm going to graph it. I'm going to do 18 multiplied by 0.5 raised to n minus 1. That is the definition of the nth term of a geometric sequence. U1 times r raised to n minus 1. So you do n minus 1 and I press enter, right? This is not the screen that I'm really happy about. One way, I had shown you a different way. This time I'm going to show you just a simpler way. You click on here until you see, you get the grab. You see the hand, okay? And I just grab and I just kind of adjust it to the place that I want. Okay. This is one way. The other way I told you was to click on this and change these boundaries, the end values, change the end values, all right? And this way I'm happy with this, all right? And you can still do this. I can still do the 20 or the 25 or whatever I wished, okay, all right? So this is your U1. You still can't see the U1. If you're interested in seeing the U1, I'm just going to make it 25. And now you see the U1, right? Now, since this is a graph, it has got a contextual menu that I was talking about earlier. You go to the menu and you want to trace the graph because you want to see these individual values. You graph trace, right? And you see I'm graphing, so I can use the navigation here and look at all the terms that I want to. This is the first term, the second, the third, the fourth. But my interest is looking for the term that is less than 1,000. Less than 1,000. 1,000 is 0.001. I'm looking for a number that is less than 0.001. So I move on, I click in here, and when I come to the 15th term, it says 0.01. Well, I need a number less than 0.01. So it is the 16th term. But I did show you how to be doubly sure or just be a little bit confident about your understanding of the question. So you can go to do Control T. This gives you a table of values and you can scroll down and find the values. The same thing in a different representation. Do you see how dynamically linked all the operations are? Like I'm using the graph, but within a graph, I am using a table of values that is so informative, right? And look for your math IA. Then you can represent the same information in so many different ways. So you go down, right? I scroll down, I scroll to the 15th. Okay, the 15th is 0.001099. It's slightly higher than the 0.001 that I'm looking for. So this is the 16th term that is less than the 1,000 that I was looking for. I showed you we can have the same information done on the calculator page, right? Since I've defined this, I'm going to add another page. And the last time I added it using the plus here, the control dock. This time I'm going to use the other way that I showed you. I'm going to insert, and this time insert a page. And I'm interested in the calculator application. And all these pages, this page and this page is linked together. Anything that you define here will be recognized by the calculator on the additional page that you create. And I have defined my sequence to be UN. So when I want to find, let's say I want to find the 15th term. Of course, I want to find the 15th term because I'm interested. I'm just making sure, and several ways of showing the same kind of information, representing, using different ways of representation is your communication criteria for IA. So, this one, so the U defined in my earlier examples no longer stay true for this problem. because this is a different problem. It's got its own U. So I press enter. Oh, because it was defined as U1, right? Not U. So what I'm going to do, I'm going to do U. Okay, I'm going to do U1 because that was the definition here on the graph here. Let me show you. Okay, it was U1, right? So the calculator is picky. You've got to be careful. And I want to find the 15th term. So this is the 15th term, and I press enter, and you would know because it's turned bold. So it's recognized your defined sequence, and I press enter. Right? You get this value, the same that we got in the table. You can do, so what I can do, I don't have to type, I can click here, press enter, just change this value to 16 and press enter. Right? Now, if you want it to be changed to a fraction, let's see if we can do that. You go to menu, you go to number, you say approximate to fraction, and you press enter, and this is approximated to a fraction. All right. Does it answer the question? It's almost 4:10. All right. I think we'll continue again, but if there are there's a question that is really bothering someone, I'm happy to answer it. Hello? Excuse me? Miss Swati?
Yes, ma'am. We are here. Any students, if you have any questions, please raise your hands. Madam will answer for the questions.
Yeah.
We will unmute you.
I'll take another question, and we can do this again another time. If there are no questions, that's nothing to, you may think about it, gather all the questions that you have, and I'll be happy to answer them another time we meet. Okay?
Okay, ma'am. Thank you so much. Thank you, students, for joining for the session today. Thank you for.
I hope it was a useful session. Sequences and series is a topic that is introduced in the initial few months in most schools. So we thought, introducing this topic and also showcasing all. Well, this is just the tip of the iceberg. There are so many things that you can do with the calculator, but exploring is part of the process, of the learning process. So I'd encourage you to explore. Next time we can give you ideas for Math IA, right? So you find this interesting. Yeah, so stay happy and stay learning. Bye.
Thank you, ma'am. For students, we just have some important announcement that we are going to have series of webinars from next week onwards, going deep into the subject. And this time we have changed the timing from 4:30 to 3 o'clock. So many of them have not able to join for the session today. So generally we used to share only the recorded the webinar link only with the participants, but this to share with the other students who are not able to join. But we got many number of students have registered this time for this topic. So we are going to do the series of webinars with different topics, part 1, part 2. So please block your calendar from next week onwards, Saturdays. We will keep you informed about the timing. And like we've been doing this webinars for a long time. Like after this pandemic sessions, pandemic crisis started, we started doing this webinar continuously to train the students and teachers. And we got requests from these students that they wanted to learn the basics and fundamentals of the calculators. Because now we started getting into this topics, they wanted we are planning to have this basics and fundamentals of the calculator to become how faster to work on the calculators and all. We are running a separate session. We have created a workbook for it. If any of you wanted to join for the session, please approach us separately. Swati, can you show the email IDs and contact numbers in the screen so that they can make a note of it?
Yes.
And I hope all the students who have joined for the session must be having the calculators in hand. In case if any of you are not having the calculators, wanted to buy, please approach us. You can contact the contact numbers we have given and the email IDs, you can write to them. And any other support services, like you wanted to download, you want help in downloading the student software in your laptop, or any technical issue with the calculators, anything, you can directly contact us, or via school also you can contact us. We will be we will help the students. And that's it. Block your calendars from next week onwards. Every Saturday we will keep you informed about the timing. Definitely it's going to be post lunch. Thank you so much. Thank you all.